Alright, section 5.2 goes on from yesterday where we were looking at polynomials, we're talking about their end behavior and turning points. What we're going to do today is figure out where they hit the x-axis. And where it hits the x-axis, that's called the zeros. So in order to find those zeros, we're going to be factoring like we did in chapter 4. We're going to factor these polynomials, and then we're going to figure out what makes those factors equal 0. And those are the x-intercepts on the graph. So my first example here, I've got basically y equals x to the third minus 7x squared plus 12x. I know that because it's got an x to the third as its degree with a lead coefficient of 1, so degree is 3, lead coefficient of 1. I know the end behavior is like a line that goes up to the right. So I'm going to keep that in mind for later when I get around to graphing. Factoring. First step of factoring is to take out what they have in common. All three of these terms up here have an x. So I'm going to take out an x. Now, I'm going to see if I can factor x squared minus 7x plus 12. I think that's actually a pretty easy one there. 1 times 1 is 12. It adds up to negative 7. Negative 3, negative 4. So if I were to FOIL those back out, I'd get x squared minus 7x plus 12. So this is what my polynomial function up top factors into. And what that tells me is that I have 3 zeros. And you want to keep that in mind. Because it was x to the third, that means that you could have up to 3 zeros. If it was x to the fourth, you could have up to 4 zeros. X to the fifth, 5 zeros, and so on and so forth. This one does have 3 zeros. They are whatever makes x 0, and that would be 0. Whatever makes that term 0, and that would be 3. 3 minus 3 is 0. And whatever makes x minus 4 is 0, and that would be 4. Again, the significance of the 0, 3, 4 is they are the x-intercepts. Why are they the x-intercepts? Because we're pretending that y out front here equals 0. And where is y 0? Y equals 0 is the x-axis. Y is 0 everywhere right there. So we're finding the x-intercepts. Rid of that line. Now I'm going to go ahead and just use the end behavior that I discussed earlier to make a sketch. I said because it was x to the third, it was like a line that goes up. So to the right we go up, to the left we go down. And inside here, I don't know what it's going to do something like that. I don't know how high and how low. I don't know this height right here. I don't know how low this goes right here. I'd have to use my calculator, or I could plug in. I could plug in x is 1, x is 2, and kind of figure out how high up it goes. But we're going to use our calculator after a little bit here to find these high points and low points called relative extrema. The high points are relative maximums, and the low points are relative minimums. We'll use our calculator to do that after a little bit here. Okay, so same thing, we're going to factor. In order to factor, we take out what they have in common, and 3 goes in all these. So divide them all by 3. And when you've got x to the fourth in front, you can do it just like it was x squared, as long as the middle term is x squared. So if you've got an even number for a degree, that's even. And then the second one is half of that, half of degree. You can factor just like we did above. You can say what times what is 36, and adds up to negative 13. Well, 4 and 9 are 36 and add up to positive 13. So it'd be negative 4 and negative 9. But it can't be x and x, because it's x to the fourth. So we've got x squared and x squared. If you were to FOIL out x squared minus 4 and x squared minus 9, you would get x to the fourth minus 13x squared plus 36. Now this isn't done being factored because you can actually factor x squared minus 4. That's a square minus square. That turns into x plus 2, x minus 2. And the same thing with the x squared minus 9, that'd be x plus 3, x minus 3. Because this one was x to the fourth, it could have 4 zeros, and this one does in fact have 4 zeros. They are -2, +2. What plus 3 is 0? -3. And what minus 3 is 0? +3. There's your zeros. This 3 out front doesn't do anything because it doesn't have an x with it, so just taking that 3 out made it easier to factor. So on the graph, I've got intercepts of -2, -3, +2, +3. It was x to the fourth, so it's like a parabola. It was 3x to the fourth for my lead term there. So it's like a parabola because it's even. X to the fourth, 4 is even. And it goes up because 3 is positive. So to the right it should go up, to the left it should go up. That's my end behavior. What happens in the middle? Oh, I don't know how high or how low. I kind of know how high actually, because it looks like there's a line of symmetry right here. So it would be at its highest point where y is, or where x is 0, because that's the y-intercept. And that'd actually be at 108. If I plugged in 0 at the very beginning here, you know, if I did 3 times 0 to the 4th plus 39 times 0 squared plus 108, I get 108. So I know it's going to do something like this. Way up and down. I don't know how far down. I think they actually go lower than that. We did that in class. I think they actually go way down to like -18.75. And again, we could use our calculator to figure that out. I've got that coming up in another problem, so I don't want to do that right now. Okay, I think that's it for that problem. I was asked in classes if they could tell me what domain range was, and the domain of this would be all reals, because it goes forever left and right. The range would actually be all reals greater than or equal to whatever these low points are. And like I said, I really think they're supposed to go way down to 18.75. So it'd be y is greater than or equal to -18.75 for a range, if I was asking for those. Okay, 3, write a polynomial function of least degree in standard form that has zeros up at 5, -2, and 3. That means that on my graph, I would have a dot at 5, at 3, and at -2. Well, in order for that to happen, I would need to have factors of x minus 5, that gives me 5, x plus 2, that gives me a -2 for a 0, and x minus 3. Now we just need to FOIL like crazy. So I'm going to FOIL out these first two, and that would give me x squared minus 3x minus 10. 2x and -5x is -3x. Now I've got to take that and multiply it by this one. I'm actually going to put this one in front. And I'm going to take x times all of these, so it'd be x cubed, -3x squared, and -10x. Then I'm going to take the second term and multiply it by all these, so that'd be -3x squared, +9x, and +30. The reason I line them up like this is now it's easier to add my like terms. They're kind of grouped by like terms already. So I put the x squared under the x squared. So because I put these x squared, it's easier to see it's -6x squared. And I put the x's in the same column, so that'd be -x plus 30. There's my polynomial function of least degree that could have those zeros. Because it's x to the third and it's positive x to the third, it would be like a line that goes up. So it's going to go up right and down left. And the y-intercept would be 30. I can see that if I plugged into 0 and up to 30. So it's going to go way up, come down. I don't know, again, looks like I missed a little bit over here. I don't know how high or how low. I'll use our calculator later to get that. But you could plug in points to figure that out as well. That's it's kind of like, it's an end shape basically that you get. Okay, this one's a little different. Why is it different? Because you've got two of the same. Well, that doesn't change my graph any in terms of putting a dot at 3. I can put 2 dots there, but it doesn't look like it. It just means it hits 3. It hits it twice, but you don't see it. Now we're going to talk about something that happens when it hits it twice in a little bit. First, let's go ahead and come up with our answer. In order to get a 3, I need an x minus 3. But there's also another 3, so I need another x minus 3, so I'm just going to put a square here. In order to get a negative 1, I need an x plus 1. And in order to get a 1, I need an x minus 1. I'm going to do the square dance right here. That would be first one squared, twice the product, last one squared. And I'm going to multiply these out here because those are conjugates. So when you multiply those, the middles cancel. X times x is x squared. 1 times negative 1 is negative 1. And then it comes down to foiling. I'm going to take x squared. I'm going to take x squared and multiply by all these. So it'd be x to the fourth, negative 6x cubed, and positive 9x squared. Then I'm going to multiply negative 1 by all. So I'd have negative x squared, positive 6x, and negative 9. Add the like terms and I get my answer for my polynomial function, quite long, x to the fourth minus 6x cubed plus 8x squared plus 6x minus 9. This one starts with x to the fourth, so it's like a parabola that goes up. So to the right it's going to go up, and to the left it's going to go up. And then if you try to figure out, well, also before I say figure out, the y-intercept to be negative 9. You can see that right here. So it's going to go down here, so it's going to go down, it's going to come up. We're going to run into a problem. Because you're going to see we can go up and then it's like, wait a minute, usually I go through the graph. I can't go through the graph because I need to go up there. Well, that's the big thing today. This actually right here will bounce. I shouldn't say big thing today, the big thing right now. It'll bounce off the 3. And the reason it bounces right there or gives it a kiss is because there were 2 3's. And when you have more than one of something, you're said to have a multiplicity that's different than 1. So this would be a multiplicity of 2 is what I had up there. So there'll be a test question where I ask you to list the zeros and tell me the multiplicity. And so this would be 3 is a 0 with a multiplicity of 2. Negative 1 and 1 are zeros with multiplicity of 1. And so anytime you have, well, I'll get that on this side. Let's flip it over here. So that's that. Anytime you have even multiplicity, you get a bounce off the x. So it won't go through. So if you had a multiplicity of 2, 4, 6, 8, you're going to bounce off the x. If you have odd, then it goes through the x. So if you had x to the first or to the third or to the fifth, it's going to go through. Put an arrow right here. Put that arrow on your notes there. I forgot an arrow right over here. So if I was going to do this one, I'd say, you know what? There's a 0 right here, 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 and here. Well, the leftmost 0 is at negative 6. So that tells me that x plus 6 is a factor. And I want the least degree. Well, in order for it to go through 6, it could be to the first, the third, the fifth, the seventh. Well, I want it to be the least, so I'm using the first. Okay? Now the next one is negative 2, so I need an x plus 2. But that bounces right there, so the least degree would be a square. Could be 4, could be 6, could be 8, but the least is a square. Then I've got a 1, would be x minus 1, that's a 1 right there. And then finally I've got 1, 2, 3, 4, so it would be x minus 4. I'm not going to multiply this one out, this is odd, right? This function could represent the one on the right. It's not, but it could, just based on the zeros. I'm sure the y-intercept is a lot different than what I have right here. Finally, we're going to use our graphing calculator to actually come up with those minimums and maximums. So what we need to be able to do is put y equals in our graphing calculator. Y equals this right here. And then we're going to use some keys here and bring up my calculator in a second. Okay, so I've got my calculator brought up. And I entered y equals 2x to the fourth minus x to the third plus 2x squared minus 3x plus 1. What I'm going to do now is graph. And I don't know where my window was at. My window's at negative 10 to 10, negative 10 to 10. And I get it like a parabola shape. It's not a parabola, it's like a parabola. Well, this was 3x to the fourth, right? So that tells, or 2x to the fourth, it's 2x to the fourth. So that tells me that I'm probably looking at the graph right here. It's probably pretty accurate. I don't need any more. It it probably just keeps going up forever and ever because the x to the fourth tells me it's like a parabola, and the 2 tells me it goes up. So all I'm going to find on this one is a minimum because there is no maximum. It's going to go up forever left, forever right. So I'm going to try to find this minimum right here. And here's all you do for that. Second, here, let me start over here. Let's clear my history. Okay, so let's do second, calc. Oh, now it's tracing. We got to start over. Clear again. All right, start from scratch. Second, trace, and I want to find a minimum. So I'm going to hit number 3. And now I've got that blinky that we've talked about before. Okay, blinky is blinking right here. They want to know, is blinky to the left? Is blinky to the left of the point we want? Yeah, he is. So I'm going to go ahead and press enter right there. And then I'm going to go ahead and arrow to the right to get blinky to the other side. And press enter right there. And then do I want to guess? Yes, please. And then you get what your answers are. 0.595 is the x, and negative 0.037. We'll go to 3 spots as the y. So 0.95 is the x, negative 0.037. And that's what you're going to write. 0.595, negative 0.037 is called the relative minimum. And that's what you're going to use to figure out those high points and low points. You're just going to plug it in your calculator and use either the min or max function. The last problem I have is that same idea. What you've got is a 10 by 12 piece here, but you're going to divide it up. This is going to be an open box with no lid. And the bottom of the box is right here. So you've got volume equals length times width times height. I remember that from geometry. And the length of my box would actually be this bottom part right here. Well, it's not 12 anymore because I took out this chunk here and this chunk here, and those are supposed to be the same width. So my new length is 12 minus 2x. My new width is 10 minus 2x. And my height is x. And what you do from there is you put that in your graphing calculator. You don't even need to multiply that out. You just put that in like that. Put that in like that, and then you're going to go ahead and find the high point using the max function. But if you need help with that, go ahead and ask. As you heard the buzzer ring, I'm out of time. Thanks for watching. Have a great day.